Hey everyone, welcome to example 2 of writing or expressing complex numbers in polar form. Okay, just a quick review. These are the things we're looking for. If you've watched video number 1, we need to identify A and B, our R value, our modules, which is a distance, and to write any complex number in polar form, we need this equation right here. So this is just a review. This is video number 2. Okay, and remember these steps to solving. I like to identify A and B, may expand if I have to, if it's in the form of A plus BI to the N. I then find R, then find theta, then substitute into my formula. And so that's what we are going to be looking at when we convert. We've already done the first example. That was the first video. Now we're going to use the second example here. Okay, so I'll try to keep this together. So first we're going to identify A and B. Okay, so I just like to rewrite my number. So I have -3 minus 4i. Okay, so identify A. A is the real part, -3. Okay, here's our complex part, our imaginary part. B is going to be -4. Okay, so what I'm going to do now is I'm going to go ahead and find R. Let me fix that. So I'm on step 2, find R. So R is equal to the square root. It's a distance of a squared plus b squared. Ignore the signs because you're squaring a number, always positive. So we have -3. I'll just plug that in for you, but you know it's going to be positive, so you really can ignore those signs. I'll put it in there for this example. So we have the square root of 9 plus 16. If you square those out, that's root 25, which equals 5. So I have my R value. My R equals 5. So I'm on my way. Now I got to find theta. And what I like about this example is that we go ahead and do this. Okay, we're going to draw this. So we have -1, 2, 3, 1, 2, 3, 4. So we go down here. So here's theta. Okay, that's -3, -4, opposite over. So we're going to use tangent here. So we have tangent of theta is equal to opposite, which is -4, over adjacent, which is -3. So we're really looking for the tangent of theta equals 4/3. Okay, now that is a little bit tricky. Okay, let's see if we can zoom in on my graphing calculator here. I've actually done it already, but we'll go ahead and do it again. Okay, yeah, we're gonna have to zoom in. You can't really see that. So I actually am going to take the inverse on my calculator. So I'm going to say inverse tangent of 4/3. And when I do that on the graphing calculator, I get approximately 53.1301. That's degrees. Okay, so we can go ahead and look at that. So we've got the degree here. I have my R. I have my theta, right? That's what theta is, right? Inverse tangent of, so it's, theta is 53.1301, roughly. Okay, so I've got R, I've got theta. Now I'll just write my answer in polar form. Okay, so we'll go ahead and say Z is equal to R times the quantity cosine theta plus I sine of theta. Now you can round here, I guess, to make it clean. We have R is 5 times cosine. We could say 53.1301. I'll put that in. There we go. Plus I sine of 53.1301. Okay, so don't be surprised if you actually have to use your graphing calculator to help you find theta. It's not always going to be an exact value on the unit circle. So this is -3 minus 4i in polar form. If you have any questions or comments, please type them below. We'll see you next time.